Hi everyone, so welcome to the module 13, Data Visualization. In this module, I'm going to tell you how to use Python to plot different graphs. Before that, we need to do the following preparation before we work on this module. If you do not install Pandas Data Reader library and Seaborn, you may have to use the following command to install this library first. So here, we first want to install Pandas Data Reader by typing type install pandas data reader, and then we are going to install Seaborn, and after a while it's done. Next, we are going to import some libraries that are needed for this module. First, we install the pandas data reader library and call it pdr, and then we import pandas as pd, and we are going to import datetime from datetime as dt. And then we're going to import matplotlib as plt. And lastly, we are going to import Seaborn as SNS. Now, we type the following two codes to set the basic style and theme for matplotlib and Seaborn to make the graphs look better. Let's learn how to use basic plot to plot stock price and returns over a certain period. Then we try to set our time frame. Here we are going to get the data from end of July 2020 to end of July 2022. So we have two variables to save the start date and the end date. And then we are going to save the stock price of Apple to a variable Apple. So later we are going to use the plot method to plot the closing price column in the dataset. If date format data is saved in the first row in the dataset, the data in this column will automatically be used in the x-axis. So that's why when we plot the closing price, you should be able to see that the x-axis would be the time. Next, we are going to get the stock price for 5 stocks: Meta, Apple, Amazon, Netflix, and Google. So we're going to save these 5 tickers in a variable called stocks. So it means that we are going to use a list to collect the stock code and retrieve the stock price data of the 5 stocks based on the list. Then we are going to save those data in tickers. And here we use a method called sort index. Sort index method will sort the data frame according to the index, which is the date in this scenario. Next, we are going to estimate the percentage change of the daily stock price by percentage change method. It could calculate the percentage change of the current observation from the previous observation. Then we try to estimate the cumulative returns. We add 1 to the value of df1 and use cumulative product method to calculate the cumulative returns for every observation. So lastly, we're going to plot the cumulative returns. Here, you should be able to compare the performance for the 5 stocks over the period. See, now we can see that actually Google seems to be perform the best and Netflix seems to be perform the worst. A bar chart shows data by category with rectangular bars with height proportional to the values shown. The easiest way for us to get the cumulative returns is to utilize the previous data. So here we use ilocate -1 to retrieve the last vote of a data frame using ilocate. This is already the holding period returns. Then, if we do not did the previous job, we can actually compute the holding period returns by comparing the ending price with the initial price. And to do this, we first get the ending price with the index -1, and then we get the beginning price with the index 0. Then we can estimate the changes, and the changes divided by the opening price, you should be able to get the cumulative return over this period. See, they got the same result. Then next, we want to calculate the number of years between the last observation and the first observation. To do this, we first estimate the difference in date. After we get the difference in date, we divide it by 365 to get the difference in year. So here we use date method to convert a datetime object to an integer. Next, we calculate the annualized returns using this formula. Now we are going to plot the cumulative returns in a graph. Here, we can do in two ways. First, we can either set the parameter chi equal to bar to generate a bar chart based on the data stored in the AR. Or we can use the plot.bar method that could help us to generate a bar chart. From this bar chart, now we can confirm that Google performed the best. Lastly, we want to check the average initial returns in module 13 by the attribute of IPO. Here, we first upload module 13, then we try to read the data from the Excel file in the data frame df2. Next, we are going to use the group by method. It groups IPOs by their attribute. The group by method returns a group by object that contains information about the groups. The min method can generate the average of each group on the group by object. The last method, plot, generate a bar chart of the by group average returns. When we're using all of the methods, you should be able to get this statement. And when we run it, now you should be able to see that this is the returns by attributes. A histogram shows the distribution of a variable, whether the height represents the frequency. Let's try to use histogram to show the distribution of Netflix daily stock price. We use plot and then we set parameter chi equal hist, means that we are going to generate a histogram. But you can see that there are only 4 bars, which make it hard to understand what does it mean. Then we can set a parameter beans equal hundreds. The default value of parameter beans is 10. By setting a larger value of parameters bean, we can see more bars shown in the histogram. Alternative code for us to get the histogram is to type plot.hist. And after you type it, you should be able to get the same result. Now we are going to show the distribution of daily stock returns for the 5 stocks at the same time. Here we use plot.support. It helps us to create support so that different charts could be shown at the same time. The first number, 3, means the number of rows of our support. The second number, 2, means the number of columns of our support. And the third number, 1, is the position of the following support. Next, we type plot.hist. This plot will be located based on the previous statement setting. The parameter color changes the color of our graphs. The parameter title can add the title of our graph. So here we add another support, which is in the next position. And we're going to show matter histogram. And we are going to show it in red with a title matter. Here we are going to make 2 supports, one Apple, another one for Amazon. Then we also add one more support for Google. To adjust the size of supports and space between them, we can use the plot.support adjust method. The parameter left, bottom, right, and top adjust the size of the supports. And W space and H space adjust the space between columns and between rows. So when we run it, now you should be able to see the 5 histograms. And they will be in different color and in the position that we designed. A box plot shows the key summary of a distribution of a variable with a box-shaped graph with tails in both sides. There are 7 key statistics in this graph. First, median. Second, the first quartile, Q1. Third, the third quartile, Q3. Fourth, interquartile range, IQR equals Q3 minus Q1. Fifth, minimum but no smaller than Q1 minus 1.5 times IQR. Sixth, maximum but no larger than Q3 plus 1.5 times IQR. And lastly, outliers with the value outside the range between minimum and maximum. Let's show the distributions of daily stock returns for the 5 stocks using boxplot. Here we want to base on the closing price, and then we sort the index and using it to calculate the percentage changes, and then we are going to plot the percentage changes in a box plot. If you run it, you should be able to see that there are 5 box plots here, and now you are able to see some outliers, and then minimum, first quartile, median, third quartile, and then maximum, and then some more outliers. Scatter plot is a graph that shows the relationship between two variables, whether a variable shows on x-axis while another variable, usually the dependent variable, is plotted on the y-axis. Let's show the relationship between initial returns and cumulative returns using the data frame in module 13. Here we want to create a scatter plot with the method plot.scatter between initial returns and cumulative returns. As cumulative returns could be affected by initial returns, we put cumulative returns in the y-axis and initial returns in the x-axis. So here, we want to type s equal 5 as the parameter. The parameter s determines the size of the dot in a scatter plot. Next, we are going to explore the relationship of the stock returns between Apple and Google. Here, we use the plot scatter method. We type x equal Apple and y equal Google. Then, we are going to use xlim and ylim methods to help us to zoom in or zoom out. By setting them between -5% and 5%, we can have a clear view on the co-movement between the two variables. A pie chart shows the contribution by different categories, comparing with the total. Now, we are going to divide the total number of IPOs by their attributes. First, we type count equal df2.groupby attribute.count lot size. Here, we group the IPOs in the data frame by the attribute column. Then, we use the count method to count the number of IPOs in each attribute group. As we have no null value in any cell, we can pick any column for counting. Next, count equal count.rename attribute that helps us to rename the series by attribute. Then, count.plotPie auto percentage. Here we are going to generate a pie plot with plotPie method. Set the parameter auto percentage to show the percentage of each attribute group. Here you should be able to see that the largest group is N, and then B, and then others. Count plot is very similar to histogram and is used for the count of the number of observations by category, while bar chart is used to describe a matrix of each category. Here we want to show the number of IPOs by attribute. Count plot method can plot the number of observations for each category, and the parameter x indicates the column that is used to categorize observation. Here you should be able to see that the number in each category. Then we are going to show the number of IPOs by attribute and year. So here first we create a column called year based on the column date. Then we are going to use the count plot again, and the parameter Hun can break down a category to a number of subcategories. For example, instead of showing the number of observations of attribute N, we will show N 2020, N 2021, and N 2022. Distribution plot is similar to histogram in plotting the distribution of a variable than a histogram. Now we want to show the distribution of the daily stock return of Amazon. Here we use the displot method. By setting true to the parameter KDE, we can actually plot the kernel density estimate line in the distribution plot. Alpha determines the level of transparency of bins. And this is the distribution plot. So in case this method does not work for you, you can try the following code to upgrade your Seaborn library and restart your program. So pi install Seaborn upgrade user. So after you type this code, you should be able to run above code. If we want to plot two histograms in separate figures, we should use this plot method since this method is a figure level method, meaning that a new figure will be generated every time we call this method. Now you should be able to see that we got the initial returns and cumulative returns, this plot. If we want to plot two histograms in the same figure, we can use hisPlot method instead. So now we want to plot initial returns and cumulative returns in the same plot. And when you run it, you should be able to see that now cumulative returns and initial returns are shown in the same graph. Although many graphs can be produced by Matplotlib and Seaborn, it will be easier for beginner to use Seaborn. Here, we're going to show the relationship between initial returns and market cap using Seaborn. We use Seaborn.scatterplot method. It is actually similar to plot.scatter method. Then the x would be the mid market cap and the y would be the initial returns. And we set xlim from 0 to 20 and ylim from negative 0.3 to 0.3. And when you run it, you can see that this graph actually is quite similar to the one that we used before. We want to show the relationship between initial returns and market cap by attributes in the same graph. So here we use Seaborn scatterplot. The parameter Hun splits a category into subcategories by categorical column. So in this case, it is the attribute, and then you should be able to see that now we have the scatterplot by attribute. Join plot can show the histograms and scatterplots of two variables at the same time. Here we want to show the distribution of cumulative returns and market cap and their relationship. We are going to use Seaborn join plot method. Here the dataset is df2 and x variable mid market cap and y variable cumulative returns. And then the kind would be scatter. When we run it, you should be able to see the scatter plot between these two variables and their individual distributions. Next, in case we want to show the distribution of stock returns for Amazon and Netflix and their relationship, what can we do? Now we want to get data from df1 and x becomes Amazon and y becomes Netflix. And when you run it, you should be able to see the scatter plot between these two stocks and also their individual distribution. Pair plot is a graphical representation of a correlation matrix which shows a matrix of scatter plots between different variables in a dataset. Now we are going to show the pairwise relationship among the stock returns of the 5 stocks. So here we use Seaborn pair plot. Because we have 5 stocks, so actually it will take some time because we are going to have 5 times 5 scatter plots. So Seaborn pair plot method generates scatter plots for every 2 columns in the data frame. And now you should be able to see the 25 scatter plots. Heat map is a 2-dimensional graph to show the magnitude of a variable in different categories, using a warm to cool color scheme to show the magnitude rather than a number. Here we want to show the correlation of all variables in the data frame in a heat map. So we type correlation1 equal df2.correlate. So we want to use the correlate method to find the correlation matrix first. Then we use the heat map method with the parameter cmap equaling to cool warm help us to generate a heat map for the data frame. Then we use vminimum and vmaximum to set the values for lower bound and upper bound. A warmer color means that the variable close to the upper bound, while cooler color means the variable close to lower bound. Good, that's all for Module 13, Data Visualization. I hope that you enjoy this module. If you want to do some practice, you can try to do the following exercise. So thank you so much. I'm looking forward to see you in the next module. Have a good day. Bye.